Okay, so our next speaker is Rachana Ananthakrishnan. Rachana is a senior engagement manager and solutions architect at the Computation Institute and has a joint staff appointment at Argonne National Laboratory. Rachana is a member of the Globus Online Services team, where she works with researchers from various domains, designing solutions for secure research data management. She has worked on security and data management solutions on various projects, including Earth System Grid, Biomedical Information Research Network, BIRN, and Exceed. Prior to that, she worked on the Globus Toolkit engineering team, leading the efforts in core web services and security technologies. Rachana received her MS in computer science at Indiana University, Bloomington. Welcome.
Okay, I hope you guys can hear me. Is this okay? The back? Yes. Okay, so this talk is going to be a little different from the rest you've heard. I come from a team that does a lot more infrastructure services. So if you look at the space that was discussed today in terms of policy needed, what sort of metadata, what sort of the structure needed towards what people need to do for data management, one aspect of it is what services and capabilities, what tools do you give them to make it simple and easy for them to do some of these things, right? So my team predominantly is a software product team that focuses on data management for researchers. It's a little different tack, more towards sort of what you heard from the RDA discussion, I think. So I decided I'm not going to motivate the need for data management. I think we've done this a lot of times today, right? But just a very quick slide in terms of saying the one aspect of what we see often is a need for this data to move around, right? So if you look at large collaborations, I often work with large collaborations, both university settings, sometimes researchers in different university settings, you see that the data moves to different storage systems, gets analyzed, transformed. So this is a classic example of data coming out of some instrument, right? Once the data comes out, there's like initial processing that's done in situ, potentially reduction processing. There's provenance, metadata that you capture at that point. Then the data moves to the next analysis. Larger groups of people are given access to the data. Then a lot of other derived data gets generated. So it goes through multiple of these. So the standard big data numbers of, velocity, volume, variety of data, the different people who need to get access to it apply in sort of all of these things. A lot of different speakers today motivated beautifully some of the things that I'm going to talk about. So to sort of scope the sort of things that we have worked on and the rest of the talk, the slide talks about a few of the data management user stories we hear about. What do users want to do with the data that they're collecting, right? So classic, where do I store it? How do I back up my data? How do I archive the data? A lot of them go to their institutions to do this, and then we work with some of the campuses on how to make it easy for the users to do this. How do you automate it? Make it simple so that users don't have to think about how this needs done. How can I quickly move the data? So the previous slide sort of motivates this idea that we think data gets collected, stored in a location, archived, but a lot of times subsets of data move around quite a bit. So how do you make it simple to move, track this data? And the third aspect of it is how do I share it securely? A lot of the researchers, the use case you hear from them is, I've acquired this data, I've done some analysis, now I want to selectively share. It's not all public. They want to share subsets of the data with users, different subsets with different users, different permissions. Then you have these questions of how do we get all these guys' accounts? How do they log in and get access to the data? How do I track those things, right? And then, of course, how do I publish my data? So when you're at a point where you have this immutable data set that relates to a publication or any point in your research where you're ready to share with a larger audience, then how do you publish it? And then the last one, how do you discover published data? How do I do the right things so I'm able to search for this data and effectively find the data I'm looking for, right? Obviously, this is a highly incomplete set. There are a lot more things that people do with data management. But for the purpose of this talk, I'm sort of going to focus on this. This is sort of what my team has been working on, and we're striving to address on this, right? One of the excellent part that was proposed as a part of this talk is this project I work with. I only know them as ISIMEP, so I had to put a bullet point to know what they are. It's the Intersectoral Impact Model Intercomparison Project. Basically, what they do is they take the climate models that are run, and then they do the secondary analysis on impact in various sectors. How does it impact the economy? How does it impact, land use, agriculture? So that's the sort of thing that they do. It's a pretty exciting project because it's a very cross-domain project. So because there are multiple sectors, they're able to inform each other of what the results they're looking at and and what they see as defects in models, how do you correct them, and so on. It's a very exciting project. One of the PIs is out of University of Chicago. Right? If you look at the use cases he brought to the table, it's very similar to the general ones that I put up, right? Worldwide research, a lot of the data sets have to be managed by this collaboration, right? All of them have different funding sources. It's not like they can take one institution and say, you manage my resource. They need to have restricted sharing. During the time they're running their models, they only want some of them to be able to access the data. But some people have rights to write into the archive because they're actually a part of the collaboration. But most people only have read rights on the archive. They should be able to just pull out the data. But still, it's a fairly collaboration setup. So there is no governance model. It's not, so that is such that it can be strictures of giving everybody accounts on all the systems, right? Then obviously publish the results. They've gone through 2 phases already. In each case, they want to be able to move selected results to a location, track metadata. Right now, most of the metadata is file names. You better know which directory you're looking for. You better know what files you want. Otherwise, good luck to you, right? Or they email the mailing list, right? I'm looking for this data. Can somebody help me? So how do you do a better job of tracking some of this data? This is just one example of what I see across the board. A lot of people have similar use cases and need for similar things, right? So what do we do? The project I work for, Globus, this is sort of a pithy line here. Big data, publish, transfer, and sharing with Dropbox-like simplicity directly from the storage system. And I'll explain each of these, right? So we just got into the publish space, but traditionally we've been working on what are the data management pillars that we can support, right? Being able to move data easily, being able to share data easily, and then we're starting to work now. We're in the pilot phase of how do you publish the data easily. With Dropbox simplicity, I mean, we put this in here more to convey this idea of something that's very simple to do, something accessible, easy for the researchers to do. We had this interesting lunch conversation about how if you increase the effort it takes for the researcher to do anything from his normal thing, right? Oh, go here, add your metadata, then talk to somebody to do some of these things, they're never going to do it. One of the colleagues talked about forcing a mandate which said, in the UK, in one of the research facilities, they said everybody has to fill out these 3 forms before they would accept data into their archive. 60 to 70% of metadata was useless. Everybody had John Doe. Everybody had random numbers in their GUP. They scripted around it. I would too, right? So the Dropbox thing, analogy here is merely to say what you can do in other places, right? You could stream music easily with Netflix. Or you can stream movies using Netflix. You have iTunes. Everything has evolved into this very simple interface. How can we bring that into the research world? That's one of the big thrusts of my team. Directly from your storage system. So this is another big aspect of researchers today. For various reasons, for the volume of data, for security of data, there is reasons to keep cost purposes. You want to be sharing and using the storage system that's available to you through your institution, right? Not everybody is able to just move the data to the cloud or use Dropbox for these purposes. So our team is focused in the last about 5 years on bringing these tenets into it. We have the transfer and sharing in public, in production, and available. A lot of campuses, research institutions actually use this for moving the data. And we now have started in the world of the publish side, right? So I'm going to talk a little bit on the publish today and then sort of point out why the other bits are pillars that support the publish operation, right? So here's a simple walkthrough. What are we trying to achieve out of this, right? So all of these services are software as a service, which means it's a single instance that we host and run. So everybody doesn't have to download, compile, and install these things. We run them as an instance. It's like going to Amazon or something, right? So here's an interface of Globus Publish, right? We look at these as independent collections. Every institution has their own collection and the context of where you put your data. So a scientist who has some data and metadata, so he has some data sets associated with a publication and he wants to push that into his institutional repository, right? So first thing he does, publish the data. So he starts the workflow to publish it. Describe the submission, and there are 2 aspects to it. One is the general metadata you provide, about the authors and things, but also about scientific metadata. More and more searches happen based on sort of scientific metadata. Argon battery research is a huge deal, right? So they have metadata like what is the energy levels that this thing works on. So you want to be able to query on those things when you discover the data. Then a scientist actually has data sets associated with it. So it's not just a paper. So then he moves the data assembles the data set that's relevant to the publication and moves it into the repository wherever it's going to get archived or it's going to. Then comes the curation workflow. I'm not going to go into this here. This is sort of somebody validating both the data set and the metadata itself, right? So this is sort of the publish workflow we have tried to build on top of DSpace. We took DSpace as one of the software. It is simple to build, and we are looking to see how we can extend it to add the capabilities that it needs, right? So here's the first step here, logging into the system. So somebody decides to publish. They have to first identify themselves with the system, just logging in. We've integrated campus logins into this, so somebody can just come in and use their University of Chicago login to just use the system. They don't have to worry about creating a new account and such. Then comes this idea of submission, right? So the first thing you say, I'm choosing the collection to submit. You can set permissions on what collection somebody can submit to. So here somebody picked the Center for Nanoscience Materials. This is a big center at Argonne. Then there's a colleague of mine who actually is a researcher there. He describes the paper that he has written. This as a standard input that you give. You see ORCID IDs and author descriptions. But that's the interesting part where we start to get information about the experiment itself, right? So domain-specific information. What is the material he used? What was the energy density of the material? And these are all key information bits for the discoverer of the data. So like in the last talk, they were talking about how do I help my students find the right set of data? This is the sort of piece of information that's going to help these search, right? So you can go and look for this information. So the scientist can enter that data in there. Now comes the interesting part of assembling the data set, right? Now, I want to put pointers to the data. So data is not getting moved anywhere, but the institution has the storage. So you want to put pointers to the data. So here's an example of this guy picking up all the data that he had in his local laptop, hard drive, right? He's putting all the data into his submission. We create a separate location that only he has write access to for now. And he puts all the data that he sees as relevant for this publication into that location, right? So that's him sort of reviewing it, making sure he has all the right data sets and so on. And then there is a license aspect of it, obviously. So sign off on the license, and then that's where you do the submission, right? So there's a step where it's now in the hands of a curator. At this point, the curator logs in. Very similar. We have tried to integrate as much existing logins as possible. And then has the opportunity to review. I'm sure anybody who has DSpace as an institution repository is familiar with these things. But at this point, we sort of integrated both the metadata aspect of it and the data set. So the curator now has read-write access on the data set. So he can actually go look at this data. He can download it, look at formats, is everything right, and so on. So he's not just looking at the metadata for curation, but actually looking at your data files also, and has the opportunity to actually kick it back to the scientist if need be to say you need to fix some of these files, right? Behind the scenes, we are sort of managing the storage and the permissions on it so that we do the right things with the scientists and the curators. So once you approve, then it goes into the repository, and then all this is DSpace magic. You get a handle and things like that, right? Now comes the discover aspect of it. So what if this is a student who is looking to find some of this information, right? So you want to allow search. And very simply put, I want to allow search like you would on Amazon, for example, right? Be able to set parameters that is more than just, large level area. You want to be able to say as fine-grained as possible. So they're able to go search and discover. But more importantly, if they have permissions, they're able to actually get to the data set, right? Not just find the paper, but actually be able to get to those associated data set that the scientists put in there, right? So here is a snapshot of discover data. We sort of enhanced the search aspects to be able to say you can search across collections if you would want, or you can narrow your search down by collections. Here's an example of more of a faceted search style, right? So here it says, I want to see materials with energy density greater than 1500. So only the papers that are relevant to that come up in the search. So how can we make this discover capability more and more sophisticated so that the user is able to find the data more easily, right? And then once you find it, then in addition to just having access to the paper itself, you have access to all of the data set. This is if the scientist chooses to release it. There are permission questions on those things, right? So the system is built such a way that you could make this where any public person, like anybody outside, is able to just search and find the data if that's what it mandates and that's where you are. Or in some cases, we have large collaborations where within the collaboration they need to share, right? Classic example is the argon photon source. We have people come in and run experiments at the photon source. but only 1 or 2 people will come in to run the experiment because they need gate passes and they come and actually do it. But they have collaborators worldwide sitting back home trying to do some of this stuff. Then you can publish, you can put in all your metadata and make it accessible, but then make it accessible only to that group so that the data is available only to a smaller group, but then you still have the process of making sure you have the right metadata and you're going through the process, getting ready for making it available, right? So the download is simple. This is him trying to get it down into his desktop, right? Somebody searches and is able to pull the data down into their desktop. So the idea here is to see whether the idea here is both the notion of how can we integrate some of these interesting bits of metadata, the actual data set, scientific data into a lot of this, make the workflow simple. But the key also for us is usability and accessibility, right? We have strived very hard to bring that aspect into research data management, which is what we have sort of backed this idea of a software as a service, which has really good UIs, and make workflows as automated for users as possible so we're able to do some of these things, right? So this is a picture of sort of under the covers, right? And dwelling on what does it take to produce something like this? So this is our some of the capabilities that our service provides. Under the covers, we have a basic transfer service, and this is just a high-performance transfer service that lets you move data by just going to a website and saying, here is my source, here's my destination, and on a single click, and the data moves for you. It's automatically tuned. It takes care of false retries, so your user never has to worry about actually getting the data to the destination. It's sort of a managed data transfer service. On top of it sits our sharing service, and we heavily leverage that for the publish. That lets you set permissions on subsets of data. So you can say, I want to pick this directory and share with this group of people. I want to pick this directory and make it public. So you can sort of share, just like you would with Dropbox, but you could do it from your storage system itself. So those are two things that are sort of pillars behind this. And then we also have very strong identity and group management system that lets us manage all these different accounts. If you really have a collaboration that's cross-institution, cross-domain, all these people have different accounts, all these people have their own domains there. How do we integrate those things and link those things? So that's another aspect that we already have. So the publish service sitting on top is leveraging all these different paradigms to bring that seamless integration for a user where he's able to come in with his usual campus account or his well-known account and run some of these things, but backed by storage sitting in his home institution, be it his campus or a research organization, wherever be it, right? We also have APIs for all of those things so that, if you write, for example, I work with the Earth System Grid. They have their own front-end portals that their users are used to, and they like using that as a way to interact with their system. So we actually have integrated such that you can come in with the ESG portal, you can come in with the Earth System Grid portal, but you're just leveraging some of these capabilities, right, rather than writing those on your own. So we have APIs that let you do that, so you're able to leverage those on your own. On the other side is how we interact with the storage system. So you see a bunch of logos there. These are some of our early adopters who have already deployed these on their campuses, where their storage systems are accessible for this and ready for us to be able to leverage this as a capability itself, right? So on top of this, using this API is our own front end, which simply is a web page. If you go to globus.org, that's pretty much the front end for any user. You can create an account and try to transfer or share data from there, right? So I put in the URL here. It says globusonline.org. I'm sorry, it should say globus.org. We rebranded from Globus Online. I'm still teaching myself not to say that. You can use transfer and sharing. Like I said, that's available in production. It's been available for the last few years now. Publish, we just started. We actually just did an announcement of that a couple of months ago. We've done pilot phases, and we're starting to recruit users. We're actually working with Elizabeth and the UC Library also on looking at this some more. So if any of you are interested, if your institution is interested in exploring any of these things, we would be happy to hear. We'd also be happy to hear comments, feedback, criticisms. Tell us we're crazy. Everything is welcome. My email address is up there. And then we have our standard email address there. I will finish with our required sponsor slide.
Are there any questions?
Are the slides all going to be posted?
Are the slides all going to be posted?
If we'd like to do that, we'll talk to the presenters, and they will be integrated, and then talk about what we online.
Okay, so we need to clear that with the presenters, but we hope to.
Are there policies at the University of Chicago about depositing or storing data?
I shall defer that to Elizabeth gladly.
We are a particularly policy-averse institution, I think, so there is not a lot of requiring certain things of researchers. So no, we don't have anything like that. In fact, it becomes one of the reasons why having services that work and that work easily for people is really of an advantage, because it's a way of getting buy-in.
We've had grassroots efforts, I think, like
Yeah.
Rob Garner. I mean, there have been people in the physics department, for example, who have come and talked to us and said they want something like this so they can put even dissertation data in there, right? So some of the enhancements we've been talking to them about is pointers to the code they ran to generate graphs in their dissertation, right? How do I put pointers to that so somebody can reproduce some of those things? So those are the enhancements we're working on. So I've heard grassroots efforts about people wanting to do this, and some of them actually are even having some money to do this.
Right.
But nothing top down as yet.
Right.
So. Any other questions?
I have a question.
Yes.
Are there any, I guess, minimum threshold requirements to use this? Can librarians here go back to their institutions and talk to graduate students or others who maybe aren't generating large amounts of data, but this could possibly be a tool to help them?
So on basically using the first two capability, the transfer capability itself is just free. There's nothing involved in using it per se as a sign up or a fee or anything else. So anybody can go and use it. Many of the universities who actually purchase support agreements from us are providing it at an institution level. So they want a supported service. I can say, for example, Cornell has a backup archive that automatically pushes data into their archive. And the only way to access it is using this interface. They don't even want people to log in and things. So there are institutions like that we do work with, right? The other features, from a sustainability perspective, we do have a premium model here because it's a hosted service. It's much easier to get money to do brand new research. It's much, much harder to get money to operate something, right? So from the perspective of sort of sustaining the service and being around, we do have premium services for some of these. It's almost like a non-for-profit for non-for-profit sort of pricing model there. So for the publish, we don't have storage. The storage has to come from the institution, and then there is going to be some amount of fee for using the service because we store the metadata on our side, right? So the second angle we've been exploring is how do you integrate with, if you already have some metadata sitting in your DSpace or your institutional repository, how does that, like for example, how do you cross-search across these things, right? How do you make it simple so you can come to one point and search and do those things? So we're exploring those to see whether some of the things that are already in the institution stays there, but researchers start to put larger data and other data sets on this one.
Can I come back?
I just wanted to make an extra. I wanted to add a comment, which, because I know it was not the main thrust of your talk, but to really kind of plug Globus just from the transfer point of view, because you didn't really go into all of what it does, but it really is an amazing service for transferring large data sets. If you need to do this over the web, this is a not easy thing to do. And you have all sorts of problems that you might run into where something gets, interrupted and all of a sudden your data transfer gets corrupted. And it takes care of all of that. So I think one thing people can walk back and, take to their researchers is that aspect of it, is something that I've often told colleagues about, because it's one of the places they get questions from researchers, where they're kind of like, I'm going to have to just like literally transfer this by putting it on a hard drive and shipping it out to somewhere. And Globus takes care of that. And so it's a very useful thing to tell your researchers about from that perspective.
Thank you, Elsa. Yeah, I'll take that question. Yes.
So it sounds like this product is a middleware, or your project here, between the servers and getting the data to people. So my question is there a cost to it? And B, do you have to install something? Like, do you have to work with your IT unit in order to use this? It's not something, out of the box.
Great questions. So first thing I'd say, there is a middleware aspect to it. That is the way we interact with your storage system. We need a way to interact with it. It's like installing an FTP server if you want to do FTP, right? So there is that aspect to it. But we are not purely middleware. And by that I mean we already have clients and things. So if you look at a typical system, if you want to write, let's take her example. If you want to transfer a large amount of files, right? Even like 100 files across two places, then you would write your own client to do it, which would, if the transfer breaks a point, or if you have to do checksums to make sure that the transfer actually happened correctly, you would write your own clients to do some of these or use some of the commercial clients, right? So we provide both the interface that is needed on your storage system. That's something that you would have to download and install. But then we also have this where you could pretty much go log in here. It's just a web client. I'm sorry, this is a new mouse, so it's going to take me a little bit. Let's see if I can remember my password. So if you log in here, it is going to have an interface by which your users can readily start moving data. And depending on which institution you're in, a lot of them have it enabled already. So, okay. This is why you need one password, right? I have one password on my system, so it remembers everything for me. I don't type passwords at all. Okay, so I need a validate email. I can't do this without, but let's see if we can pull up the interface here. So this is the transfer interface that we have, right? So if you have either the places that you already move data from, a lot of the University of Chicago has it, NERSC, ALCF, a whole bunch. If you look for them, you can find by their names. So for example, if you move data from NERSC, you have these. Cornell has, UMichigan. So these are, you're right. So the IT department, if it's a large storage cluster, then the IT department has to install it because they're sort of setting it up with permissions. Once they do that, then it's pretty trivial for you to actually ask for a data to be moved. So in this case, these are like test endpoints that everybody gets. I don't have any data in there, but you can pick an endpoint, pick a folder there, and then just ask for it to be transferred. So let's try my University of Chicago. I'm assuming I have 2 more minutes. Can I do this? Yes. So UChicago has the IT services. I'm going to do the RCC. So this is going to ask me for my UChicago login. Oops, I hope I remember this password. So we sort of integrated with the campus login, right? Back to my campus login. Yippee. So this is pretty much my file system here at University of Chicago, right? I just use my campus login. Now I can pick any file under it that I have access to. And then this is another place that I want to transfer, let's say. And then I say move it, right? Literally what this is submission saying just move the data. And we have moved, there have been cases where a single move has been like 100,000 files we have moved in a single case where an astronomer has moved data. We have had transfers where people move like a petabyte of data. What they do is submit it to us, and then the service sort of makes sure that end-to-end it moves. It takes care of failures, if you have network glitches. If you move and then you find out that the other end, the file is changed somehow, that happens where you do checksums and see if it's valid, then we retransmit automatically. So the user literally gets emails in case his quota exceeds, or or there's a disk failure or something, then he gets an email saying talk to your admin. But short of that, we just keep trying. We've had transfers that have run 2 months because somebody was backing up a huge set of directories before their system was pulled down, right? So the idea here is how do you make it really simple for somebody to say, here, move this file from here. When you're done, just email me, right? And that's literally what the system does across those things, right? And there is also a way to move it to so your question was right on, spot on, right? First, to move it from one of the university systems or institution, the institution has to allow us to do it. So there needs to be some middleware that's installed, and it's called Globus Connect Server. It's a pretty trivial install. The stack itself has been around for 20 years. We just repackaged it to make it very simple. The middleware has been around. And then if you want to move it to your machine, we have something called Globus Connect Personal. It's like a Dropbox agent. Kind of runs on your machine, and you can do syncs between your machine and this. You set it up to say sync it, and so on. So we do a bunch of, so the transfer functionality very much is research data management, large data, secure data, right? So data that you can move to Dropbox and things like that. So this is what we do. But the thrust of it is the usability factor for us, right? You could write your own client to this, but it's very trivial to say, go to this web page and just submit those things. And then the sharing is something very, very similar. So you can pick a directory and say, I want to share it. And then you can search for people you create. Oh, I'm not set up for sharing. So you create a name, logical name for it, and then I can search for Elizabeth on the system and say, give her read permissions on the directory. That's sort of how we're set up. So big thrust on this is all usability, how to do it very trivially for the users. And along this line, we have now this publish capability, right? Building on these blocks, how do we say, now I'm ready to publish, and how do I package and publish?
Thank you. And you had a question about the cost? And the cost?
So for transfers are free. Your institution can set up an endpoint, and they can set it up. They will get community support, which means we have a support forum. They reply. They'll get answers to it. But there's no SLA. There's no agreement with it, right? Your institution can buy a managed plan. I can send around the URL that has all the different plans, which gives them, support. We promise how turnaround times on support and higher SLA and things like that. That's something as a supported endpoint. Sharing, the ability to share with the user, that's something that an institution has to enable. We can't do it because it involves the institution saying, I'm okay with that these users sharing, right? So the institution has to turn it on. So basic transfers are free. Sharing involves your institution turning it on to allow you to transfer. The publish is in pilot phase. We know it is going to be a cost model. I don't know what the numbers are because it's still a pilot phase. We are hoping people will work with us to help us refine the product and get it to a shape. It'll definitely be something, but I don't know what the numbers are right now. Because in that, there is also metadata involved, right? So how much are you publishing? What are we storing for you? That's going to come into play. We don't touch the data, so it can't be that much in terms of volume. You could have petabytes of data in your institution, but the metadata is going to sit with us. So there's going to be some sort of a value plus the storage aspect of it. But right now, it's free. Right now, it's open. We are looking for collaborators, early adopters, and honestly, partnering with a lot of the librarians, right? To put us in the realistic story of saying, okay, infrastructure, great. What is the realism into this? What are the end-to-end? What are the things do we need to make it something that's very simple for users, usable? What do you see, day to day as you help your researchers, and what can we add as capabilities? So that's the phase we are with our published product itself right now.
Thank you very much.
Sure. Thank you.